Unit 4, Lesson 1, Part 2. We're going to continue with circles and our arcs. We are looking at finding arc length this time. So if I'm looking at how to find the arc length, I got to determine, all right, that's this stuff that's outside of my circle right here. So what we have to remind ourselves, or what we have to remember, is the formula for circumference. Circumference. And again, there's kind of two of them. We can take our radius, multiply it by 2, and then multiply it by pi. Or 2 times the radius is actually the diameter. So we can do pi times diameter as well. Again, 2 radiuses put together creates 1 diameter. So in this case, I've got a half circle. So again, if this is my circumference formula and I'm given the diameter, well, all I'm going to do is take my formula and divide it by 2. So I would say that this would be pi times d divided by 2 because it's a semicircle. So again, 20 times pi divided by 2. I'm going to say that that's equal to 10 pi. So this would be my answer in terms of pi. It is centimeters, so I would want to include centimeters. If you are looking, again, to find a decimal or what you want to use for pi, you can use your calculator. There is a pi button, or you can approximate it to 3.14, 3.14159. There's kind of multiple ways to do that. 10 pi is about 31.41. We could round that to 6. Again, if I did 10 times 3.14, I get 31.4. So again, the directions will tell you what to use for pi, but for right now, we're just going to call it 31.4. Let's do 2 decimals, 0.42. All right, let's look at, well, what if it's not just a nice fancy half circle, right? This is going to be a little bit more tricky because the angle is 35 degrees. Well, we're going to create a proportion. We're going to set up something. And again, everything we like to do with our proportions, and this is what we did a lot of in geometry, is part to whole. So I'm thinking, all right, what percent of this, or what is this arc length right here? Again, it's going to match my central angle. So it's going to be 35. But I know that all the way around a circle is 360 degrees. So I'm going to put it over 360. And then I'm going to take, all right, well, now I've got to determine, do I have the radius or do I have the diameter? I have the radius. So that means I need to use this formula. 2 times the radius times pi. So I'm going to multiply it by 2 times the radius times pi. So as I work to simplify some of this work, again, let's multiply 20 times 35. That's 700 pi over 360. And so I'm going to go ahead, because that's not really breaking down into a nice number right now. I am going to just take 700, multiply by pi, and then divide by 360. Oops. I want to take this number and divide it. Use parentheses. 700 times pi divided by 360. 6.108, 6.11. Okay, so again, that would be our answer if we were looking for a decimal. And again, it's still centimeters. All right, let's try another one. Again, this central angle is 40. So that means that this section right here is going to be 40. So I have, if I'm thinking, all right, I need to set up my part to whole proportion, and I'm going to multiply it. I know the radius, so 2 times 10 times pi. And I'm going to actually try to simplify beforehand. So I'm going to say, can I simplify 40 divided by 360, 40 over 60 first? And I can, because I could take out actually 40 from each. So again, if I divide by 40, that's going to equal 1/9. And then I still have 2 times 10 times pi. So I'm going to write that as 20 pi. So we could put this into all together and say, all right, this is like saying 20 pi over 9. And so again, if I wanted that in a decimal, maybe I'll keep it in the fraction. When I plug in my calculator, I'm going to do the fraction button, and I'm going to say 20 pi divided by 9. And that's going to give me about 6.98. Bigger angle this time. Again, not really an issue for us. We can absolutely accommodate that. So again, part to whole, I am trying to find the arc length. That's what our goal is. And I'm going to take my central angle over 360, and I'm going to multiply it again. It's the radius. So 2 times 8 times pi. First things I'm going to do is simplify right here. Again, dividing by 10. So now I've got 11 over 36 times 16 pi. And I'm going to say, all right, anything 16 and 36, do they have anything in common? They do. They both can be divided by 4. So I'm going to reduce, again, 4, 9. So now I have 44 pi over 9. 44 pi over 9. And if I wanted to get a decimal, again, I could use my calculator. 44 pi divided by 9, 15.5 or 15.36. All right, 2 more examples. Again, these are, I'm sure it's kind of getting a little repetitive. I just want to make sure you get plenty of examples. The key is, again, part to whole relationships. To find the arc length, we need to take our central angle, and then we got to determine which of these 2 formulas are we going to use. Are we going to use the radius, or are we going to use the diameter? We can do either or both. Again, we can determine which one we use. 9 times 2 times pi. So I'm just looking again to simplify 130 times 18 pi all over 360. Well, I know that 18 divided by 360 is 1/20th. So I'm going to automatically simplify. Again, this becomes a 1. This becomes a 20. So now I have 130 pi over 20. And this is what I would want to plug into my calculator. $20.42. Say I wanted to use a different number for pi. 130 times 3.14159. Okay, now I'm going to divide it by 20. Oops. $159. All right, let me close that. And then I'm going to divide it by 20. Guess what? We got basically the same answer, 20.42. All right, last example. Again, set it up on your own. Try it first. I'm just going to do 6 times 2 right away. Set it up. All right, look to simplify. What can we simplify? I bet we could divide right here by 20. This becomes a 1. 300 divided by 20 is 15. So really, it's like saying 12 pi over 15. And we can simplify by dividing by 3. Let's see here. We're going to get 4 pi over 5. 4 pi over 5. So again, 2.513. There you have it.